Thanks for joining this live event. Today we will show the situation where a health and safety manager from a factory is visited by an Omron safety expert. Javier will play the role of health and safety manager, and Josep will play the role of Omron safety expert. At the end of the presentation, we will have a question and answer session where you will have the opportunity to share your doubts and requests.
Hi, I'm Javier. Today I will perform as the Health and Safety Manager.
Hi, I'm Josep, and today I will perform as Safe Automation Expert from Omron. Nice to meet you.
Nice to meet you. So, welcome to our factory. As you can see, in our company, we are producing battery cells for the automotive industry. We are implementing an efficient and flexible manufacturing by employing new technologies. Our target is to become a world-class production leader in the automotive industry by proposing an intelligent production automation system. Could you please introduce your company briefly? Because I'm not very familiar with.
Yes, of course. Omron is a safe automation supplier which advises, produces, and delivers globally, providing safe automation solutions and sharing expertise with you. Let me show a short video about our company.
Now. Not tomorrow. Not next week. Now. The world around us has changed. It's more personalized, more demanding, more impatient. To stay ahead, you need to give people what they want, when they want it, and how they need it. Manufacturers, we understand the host of new challenges you're facing. Greater customization, increased flexibility, and better collaboration. You need smarter solutions that deliver zero disruption and maximum efficiency. With Omron, you can make it happen. Let's plug and play, move and adapt, make modular popular. Let's make the production line shine while wasting less and innovating more. Let's unleash the power of IoT and set your business free. Now this is creative manufacturing, designed for the future.
Okay, it happens sometimes, but do you know which are the sources of energy that the robot gripper uses?
I don't really know, but I guess it's from an electric pneumatical gripper.
Did you know if your maintenance operator consigned the electric energy source?
Yes, he did.
Interesting. because the consignation of the sources of energy, which is the factory main sources of energy, are the parts that are delivering. So in your case, if your operator only consigned the electrical part, the pneumatics and hydraulics and other sources of energy was still supplying to the machine. So they should select, consign, release the related sources of energy which are necessary for the maintenance operations. But we have in our facilities several points or several intervention points, such as primary and secondary. You can identify in this image. But as we don't know if some source of energy is still accumulated in the pipelines and the circuits, therefore you must ensure, or they must ensure, that the energy is completely released, which is a manual procedure.
All right. I will talk with my team in order to improve the lockout-tagout procedure, and I will ensure to train all the staff members with this updated information. Many thanks. And just one more thing. I have learned that during this procedure, some operators additionally pushed the emergency stop to be more confident. Is it correct?
Well, it's not correct, but most of the people use it. Let me explain. We have in-machine safety functions, which are embedded in the circuits. So, and this reacts individually when actuated. So pushing the emergency stop removes immediately all dangerous movements, but by removing the sources of energy, something similar like the consignation. If the machine is properly designed and integrated with other machines, all dangerous movements should stop it as well. Machinery regularly is also have protective stop circuits, which has other functions. And the protect function will stop or reduce all dangerous movements by monitoring the sources of power, which is something different. Nevertheless, the emergency stop or protective stop circuits are for emergency or safety situation, not for maintenance purposes. And if the maintenance operators have an emergency stop or needs to press the emergency stop during their tasks, they are in other circuits available for help them. So they are somehow naked during this activity. So following your question, so in your case, we have the sources of energy and we have the in-machine safety functions. This was what your operator is doing regularly. So if the design, integration, validation, and maintenance of the circuits of the machinery are not working properly and not maintained properly, they are not assuring you any unexpected movements from the machinery. And that probably is the main cause of most probably what happens to your colleague. Let me show some additional animation where we will identify the control cabinet, the safety PLC, which will act all the safety logic and manage the safety logic. The wirings, the red wirings will be for the emergency stop signals, and the yellow or orange wiring will be the protective or the safety signals. And we will visualize the flashings lights through the cables. So let's see if your operator has an emergency situation. So in this case, he will press the emergency stop push button and the signal will be transferred to the safety PLC. This is considered an input. After that, as the emergency stops remove all power and energy, all movements and all motion are stopped. And during this time, the LED should be lightning or blinking. The following sequence is that the operator needs to disengage or unlatch the emergency stop, move to the main control cabinet with visibility, reset the procedure, and after that, start and react the machine. So the signals will now go to the machine, give the power, and we can continue working after everything is working. This is the case of the emergency stop. But Maybe your operator can have also another situation like a protective stop, which is very similar. But that's why I'm showing to you in this detail, because the protective situation, it could be like another operator or another situation is working and he do a movement. So in this case, detected by a safety light curtain. When the operator interrupts the safety light curtain, we visualize the LEDs and the signal is transferred through the yellow cables because it's a parallel signal. It's not the same wiring, are different functions. Yeah, and we will react in a different way, like a slowing down or a stopping. So the operator after that can do half manual reset, and after that a start procedure, so that we can have a soft starting of the machinery, and then we can continue working like that.
Thanks for the detailed explanation. Now it's more clear, and this information, it is really helpful for us. We appreciate it. Thank you.
My pleasure.
I have another question for you. Next month, we have a meeting regarding the introduction of a flexible new machinery into our production lines. Even though that we have a lot of experience regarding the CE marking and managing legal aspects, our engineering team have some doubts about how to implement it. Could you please provide more technical details about it?
Sure, I would love to do that. First, we need to understand that what is the legal framework. In Europe, assembling of the machinery and assembling within the meaning of the machinery directive, not just what you can understand in your local factory. Yeah. So the assembly or disassembly of the machinery have many technical implications. And all the examples we will show now are in the context of the safety signals are sharing the space. So that means if we have different machines delivered by different suppliers and we put all together, this is like it's understood as assembly of the machinery. So that means in this case that any of the signals, either emergency stop or protective stop, needs to stop or react of the entire line. So that means this is the context that we will move on. Rarely other machines can have a different way of working, but this is exceptional. So let me put some other way to explain. So here in this example, you will see a linear production line format or a sequence line format by several machines, in this case 4. But sometimes these machines can have a flexible manufacturing, so that means we can put in another place in our factory, and therefore there is not a line anymore. Is are individual machines. But maybe after a couple of orders, maybe next week, you will need to have reorganized the production again in a kind of sequence or a linear production. So I assume this image is somehow showing what I am trying to explain.
Yes, thank you.
So let me follow with another example. Following your example or your line, which is manufacturing batteries. Yeah. Now, manufacturing batteries, you have a static line, which is the conveyor, the robot, and other machines. And now we will add manually another machine. So that means first we need to follow the example show adding this manually machine in the current production line in the safety related context. So we should understand that the risk assessment should already include in the original design. So if not, this working mode, if not, requires a major modification, and if it's not took in consideration earlier. So that means it's a major modification. In this example, we will see how swapping the protection device signals and linking the emergency stops. Let me show how the details are doing. First of all, the operator needs to select the machine, put in the proper place, connect them. And after that, he needs to go in the operator panel. So now we will synchronize the static line, which is symbolized by the static machinery, the entire line, symbolized by the green light of the top of the light curtain. And we will add the machine. And the procedure that we are doing now is enabling. So somehow swapping the safety signals and linking the emergency signals too, with the new mobile machinery which arrives in our settings. So now the operator is selecting the signals, put all signals together. All signals will work together. The yellow are the protective signals and the red are the emergency. Emergency will be all linked, only one group. And now we will swap only the vertical light curtain and the horizontal safety laser scanner. So now the operator, the signals are all of them linked, and the operator will confirm that. So after this confirmation, the entire production line, all the machines are working together, either emergency stop signals, either protective, either vertical, either horizontal. And in this case, we will show that the laser scanner or the zones of the laser scanner will react directly in the, will affect the entire machine, which is temporarily added. Yeah. So now the operator will move in some warning area, so the detection area warning 2, and will be signalized. Now the operator is moving to another zone, and we slow down with the safety signals that you can see that they are moving inside of the copper cables. And once the operator will move to another area, the reaction will be different. Of course, now we are showing only the protective stop. If any of, in this situation, any emergency stop will be pressed, the entire line will be stopped by their own means. Yeah, and once the operator is going away, we can resume the production automatically.
That's wonderful. I like these videos. It's clarifying very much what we are asking for. Thank you very much. But I just received a message about my colleagues that from engineering team that they would like to link it automatically, but not manually, these machines. How we should do in such case?
So do you mean that the human will not interact at all?
Exactly.
Okay.
Is that possible?
Yes, it's possible. Of course, for all of that, we need to work always with the safety signals, which means safety signals work with positive logic. So that means when everything is working properly, the signals should be status on, and that means safe situation. If the energy or any causes are not under control of the safety logic or safety circumstances, then the signals are off. So the absence of the signal is considered off. Let me show also another animation where we will focus on the control cabinet for the safety PLC, where the safety PLC is embedded, and will connect with the onboard machine. This machine is automatically guided, so they own control. That's why we call onboard safety PLC or safety logic. And we will use copper cables, so standard wiring, standard sensors, but also we will use wireless signals. So in this case, using wireless, we avoid that the operator needs to be in place, put the connectors, and do the operator. Of course, everything needs to be ready and done engineering-wise and also according to the risk assessment. So we will use the wireless signal as a black channel. That means black channel, we are using the signals, the safety signals over this black channel. We don't know what happened inside. We look on the entrance of the tunnel, and this black tunnel or black channel, we will look on the results. So for that, on yellow, orange, we will signalize the protective signals when all of them are correct. In red, we will signalize the emergency stop signals. And in bicolor, red and yellow, we will show that all signals are moving on simultaneously. Each of them has different targets. So in the next example, which is what you are showing or you are asking, so we have another machine and the connection will be automatically. So let's assume we have a new batch and this operating mode should be already included in the risk assessment. If not, it's considered a major modification. So that the machine is not linked at all, it's just selected. We see an AMR or AGB, automatic mobile robot, which is coming to some slot place, which is now monitored by the horizontal laser scanners. So the machine is coming automatically in some place. And after dialogue, now we start the wireless and start the Wi-Fi signals. We start to communicate the safety signals. When the safety signals are automatically confirmed and we know in which area and position we are, then we can confirm automatically and do the enabling. So the vehicle will automatically go in a parking position. And once it's docked or parked, we enable the signals. So what is important now, and maybe I will repeat somehow the animation, you will see these areas are sweeping from another one automatically. Of course, always from large to small for positive and for safety, not on the vice versa. We are enabling. So now are enabled. So the machine is working all linked. So we are using in this case, the protective stop, laser scanner horizontal from the new machinery, which is linked temporary in the automatic way. And we will use as a protective stop for the entire robot cell somehow in order to clarify that. And you will see that the signals will be detected from the sensor when operator will go. The signals will be transferred from the logic on board, safety PLC logic on board, and switch off the signals of protective stop. And wireless will be transferred to the main control cabinet where another PLC will monitor that signals. And then the reaction will happen. So please have a look on it. Operator will be detected. Signals are changing. Protective signals are off. So only emergency stop is still working. And we see the reaction of the big robot, which is slowing down. Just for identify that. Now the emergency stop circuit is still available. So if any circumstances happen, everything is under emergency situation 2. After the operator removes from the area, we automatically restart the signals, not the functionality, and we can procedure automatically. This is how that works. And now we will show somehow how, if the emergency stop signal happens, wireless as a black channel, we will use exactly the same situation. But now the red signals will disappear because the operator will push the emergency stop signal and only the protective signals are still alive. So that means the signals are completely individually. Although they are combining safety PLC, the logic or cables somehow or functionality, but the signals are completely independent. After that, as an emergency stop, should have a reset function manual. And after that, in order to resume the production, the start procedure should be done manually, because in this case, the emergency stop cannot be done automatically. And somehow, just as example, once the production batch is finalized, that the machine can automatically undock and unleak by their own without the intervention of any manual operator. So I assume with the help of this animation and videos, I try to respond your question. I assume that is somehow clear to you?
Yeah, that's perfect. It's exactly what we need. It is exactly what we were expecting. So I see that I like your proposal, and I see that Omron has a very good experience on safe automation solutions. I believe that Omron solution is going to maximize our production flexibility by increasing the cooperation between machines, as well collaboration between humans and machinery. Engineering team will contact soon for more detailed information. Thank you very much.
My pleasure and my colleagues' pleasure. So also, if you need somehow these animations to show to your engineering team, we'll be in love to come back and show that to you. But if you want to have it in our European or in your local webpage, you can have them. If you look on the events area, you can register, and after that you will have access to these animations, because we assume that it helps to explain. So it's free of charge and in our webpage. So many thanks for your time, and hope we keep in touch.
Thank you very much. Thank you.
Now we will start the questions and answer session. So please insert your doubts in the comments section.
So,
okay, so we can see here several questions. The first one I see is, when is it mandatory to link the safety signals from the machinery?
pardon?
The first question I see is, when is it mandatory to link the safety signals from the machinery?
Well, there is no mandatory, but if you want to do machine linking without a human intervention, the best way you can do is use a wireless. It could be wireless, it can be optical transfer, etc. It can be several media, so it's not mandatory. But if you don't need a human plugging physically a connector or signals, it's one possibility that you may have.
Okay. So, second question I see, are these wireless signals safe and secure?
Well, the wireless signals, the safety signals in a regular machine are using copper cables or conventional cables. What makes this cable or this signal safe, it's working in positive, and the signal from the source to another arrive in a certain range. And sometimes also we are monitoring times, like test pulses or something like that. So in this case, we are using the wireless, any medium. It could be Ethernet IP, or it could be several networking. We are using, or it can be 4G or 5G too, or private networks. What we are monitoring is that the safety sensor is sending the signal to the safety PLC, or the communication between safety PLC and safety PLC. So at the end, we are using a completely black channel. We only look the information what we are sending, if it's receiving to the target, and the target is giving the feedback in order to close the loop. So at the end, the technology that we are using, it's invisible, transparent, not sure how to explain that, but it's not really affecting us for safety purposes. Of course, if a conventional cable like copper cable is fully protected mechanically, so to have a physical damage somehow is very difficult, but it happens, the safety or the signals are also stopped. On wireless, if you have interferences, if we have noise, if we have much more affectances than the copper cables, because are maybe not fully protected, so then of course all safety signals will be removed or switched off, and your machine will not work. So, but as soon we have a stable network, wireless, we can communicate over this network as a black channel, as I explained before, with several different technologies.
Okay, thank you. So we can see here more questions. I think this is already answered. Is the wireless safety can react fast in case of emergency?
Well, then there is another topic. So inside of this wireless network, we need to define which are the priorities. So because in most of the occasions, the protective stop, it affects directly to a stopping time of the machine. And that means we need to have larger safety distance in order to detect the humans. So knowing the amount of information that we are exchanging, then we need to prioritize that, or to have a wider space in our factory. In most of the case, that is sufficient. Not all the cases, that's true. But yeah, of course, that needs to be calculated in advance. But for most of the machinery and most of the activities, so it's more than sufficient.
Okay. Very good. So I see another question. In terms of assembly of machinery, how in practice we can understand the common control system?
Well, these are a nice definition. Okay, yeah. So there is a nice definition in the application guide of the machinery directive, which defines what is assembly machinery in the safety context. So and that define three main positions. Let me read that because I don't remember the proper wording, but for assembling the machinery, all the three criteria must be fulfilled. First is the constituent units are assembled together in order to carry on a common function, for example, the production or giving a same product. Second point is constituent units are functionally linked, such as the way that the operation of each unit directly affects the operation of other units of the assembly as a whole, and so that the risk assessment is necessary for a whole assembly. So also this second point, it's clarifying that. And the constituent units have a common control system. So for that, they can have a unique one, or they can have a synchronized one, like a network of them. So at the end, the signals or the common control system is somehow necessary for a common procedure. And in the cases we showed was somehow in the safety context. Of course, it may have several other applications, but we took the worst case for these examples.
So what more we have here? Is there a classification on when we can use the wireless safety components?
Not sure what is classification on when we can use wireless safety components. Not sure. I assume, but I don't know exactly. The wireless is what we are using is a regular one. So at the end, we are using again the black channel. So there are several wireless systems, but if they don't fulfill all the needs, the safety will not work. So at the end, the safety will stop. Related to the safety signals, safety is a generic term for two main groups of signals: emergency stop and protective stop. Emergency stop should always work on. There is no doubt. And if there is any turbulence or wireless discontinuation, latency, perturbancy, so the emergency stop will stop any machine. So at the end, it will not work. You will immediately react and know about that.
Okay. So we have another question, but I think is already answered about the stability of the wireless. Okay, we have a question about the safety sensors, how many types? I think, this I can answer, but it is just a general question. We have different types of sensors. We have sensors for safe accessing, for example, and we have sensors for, let's say, we say interlock applications, where we have a physical protection from the operator, and we have other sensors we saw in some of these animations that are without the physical barrier, let's say. Okay, so this is typically the safety light curtains you can see there, and the safe laser scanner. So in principle, we have the complete offer for sensors of safety, and we are proposing the solution in each case according to the needs of the customer. So I don't know if there is anything more that we saw some other things, but I think that well, if you use a safety system like Shift Safety when it is possible. I don't understand what it means, this question.
No,
exactly.
it's somehow a kind of response.
Oh, yeah, okay.
So just to clarify, the video that we were showing, one of the technologies that can be used is the Common Industrial Protocol based on Ethernet IP, most common name CIP safety, SIP safety. Yeah, but this is one of the possibilities that can be used.
Okay. So I think that that's all. We don't have more questions.
Or if there are more questions, we cannot see it.
Yeah, in principle, I think that's. If you want to create chat, there is something. Yeah, this question we already answered, right?
Yeah, so we see that if the wireless system is stable and fast to use in safety, well, we are talking that somehow the reaction time in machinery, it could be, or in a large production lines, it could be less than 180 milliseconds. Somehow, depending on the network and on the sensor itself and the entire configuration, you can reach somehow very fast reaction time. If we are talking that you need, or you have a very speed machine where needs the time is critical from the sensing part until the reaction part or the stopping time, you need to check the configuration. Yeah, at the end also the speed of the network is also need, and it could not work in some cases. A small machinery, probably the reaction time will be not sufficient, but for large machine like over 150 milliseconds or something like that is more than, which is common, it's more than sufficient. Okay, there is another question that what happens if the wireless connection is lost? I mean, the wireless connections question from Mr. Kudeshko. So, well, as the wireless connection is the tunnel of the safety signals, if the tunnel is closed, no chances. So there is no communication. We are sending the information from one part of the tunnel or the channel to the other. If everything is closed, the receiver will not receive, so the machine will react equally as we already press the emergency stop. But that's quite normal in this sense. Once they are linked, once they are not engaged, disabled or something like that, nothing will happen because we already enable the signals. Sorry, all my answers or my answers was once the machine is working geographically close to each other, linking, sharing the production area and space. During this time, if the wireless connection is lost, it will have exactly the same reaction as someone has pressed the emergency stop push button. Once these machines are independent, isolated, nothing happens because we already did the disabling procedure.
There is another question here about the migration. Is possible to migrate from another vendor? I imagine it means another vendor in terms of something that already is installed, and then if we can migrate to this kind of solutions.
Well, this is not a kind of vendor related. This is related to the engineering part, and the engineering part becomes as an outcome from the risk assessment procedure. So at the end, the physical layer or the vendor, the hardware that you want to use is up to the engineering team. And is not, I mean, the example we showed is not based only on Omron products. So that means we are using technology which is third party, like common industrial protocol, and several vendors can supply similar solution. Of course, we did all tests with our own equipment because that is the solution that we want to bring to the market. But other applications or other vendors could be also analyzed and tested. Yeah.
So, there is another question entering you right now. What is the hardware components needed to immigrate from another vendor? What is the hardware components needed?
Well, it's depending. So, not sure if I understood correct the question. What is clear, one of the key points or elements is the safety PLC. But the safety PLC can communicate wireless or cabling with another PLC, or the communication can be from the sensor, which is advanced sensor like safety light curtains or safety laser scanner, to the safety PLC. What you cannot do that is like the regular on-off signal, so substituting the regular wiring for that. This is some other solutions, yeah, which are existing also on the market, but are really exclusively, and the configurations works only from one product to another. What we are showing here is a standard communication is using a standard wireless information, let's say in other words, using the network of a standard Ethernet IP protocols that could be in any wireless. Again, it could be also 4G or other suppliers. We are using that as a black channel. Yeah, there are other solutions on the market which are tailor-made or only exclusive for one supplier. This is not what we are showing, or we didn't show it there.
Okay, another question entering. Is it advisable to use wireless in emergency stop, since the signal may not be fast due to noise?
Yeah, I not sure if it's fast or not, but if this signal stops or is not reaching the target, the machine will not start. So I don't see your question or your point, because at the end the machine cannot start if the emergency stop signal is not properly healthy, I will say, in the receiver side. So if let's imagine that the machine start to work with wireless connection health, yeah, so then means that all the emergency stop signals are aligned, linked, and we can start. But if during the process working, some noise start to affect this signal and has perturbances, will react exactly on the same speed as if someone is pressing the emergency stop. So because we are directly switching off the label inside of the safety PLC logic program, which is exactly like equivalent like the physical layer on the cable. So at the end is somehow no difference.
In the worst case, you lose the connection, means correct, you have an emergency stop anyway.
Correct.
So it is not for production, let's say, reasons, but for safety reasons.
Correct.
Yeah, okay.
If you have a not clean wireless, you will have a lot of noise. You will not be able to produce, because it's like pressing. The system will understand that some human is pressing the emergency stop every half a minute. Yeah. So at the end is not working. It's not a problem.
It is more related to the production. This is another.
Nevertheless, the recent tests we did at the customers, not tests, real installations, because these technologies are widely extended and vast extended since couple of maybe 2018. I mean, the last 5 years, but also with 5G private networks, with very outstanding connection suppliers and IT technologies. It works very nice. We have already a lot of reports, and if you look on YouTube, you can find also some videos proving that. But of course, this is really based on the connectivity, the wireless system.
Okay, so thank you very much for your participation. Yes.
Please don't hesitate to contact us for any further doubts or question you might have. Our team will be more than ready to help you out. Many thanks for your time. Looking forward to seeing you soon.